Hi guys, thanks for clicking. Welcome to the channel Crack It. Myself Abhisha. I have been a professional lecturer in electronics and communication engineering for over 8 years. From my earliest experience as assistant professor at MG University Kerala to today my work as GATE and ESC coaching educator at Unacademy, an online teaching platform, I have been using and collecting the best tips, tools and techniques to understand electronics and communication engineering topics. So I will help you to crack all competitive exams in easy like GATE and ESC, ISRO, DRDO, PSUs, etc. Apart from that, recent technologies and developments in electronics will be covered, which will help you to do your research works or projects. Finally, I will help BTech students in ECE stream to perform better in the semester exam. Alright, this is my first YouTube video, and in this video I will show you how we can easily understand and solve problems based on superposition theorem, which is an important theorem from our core subject network theory. Okay, so I hope you will love this video. Please do watch it till the end. I'm expecting maximum support from you. Please make sure you subscribe the channel. That will motivate me a lot. So without further wasting time, let us get started. Superposition theorem. This is a statement of superposition theorem. Before moving on to it, take a look at why we go for superposition theorem. It's an important theorem in circuit analysis which allows us to convert any linear network into its equivalent Thevenin or Norton network. So what's the advantage of converting a network into its equivalent Thevenin or Norton circuit? Do you have any idea? Can you guess? If we convert a network into its equivalent Thevenin or Norton circuit, then its analysis will be simpler one. So that's the significance of superposition theorem in circuit analysis. Got it? One more thing I would like to add. Superposition theorem is applicable only to a linear network consisting of independent sources, linear dependent sources, linear passive elements like resistors, capacitors, inductors, and linear transformers. So before applying superposition theorem to any network, we should make clear that that is a linear network. Okay? Now let's move on to this statement. The superposition theorem states that the response in a linear circuit having more than one independent source can be obtained by adding the responses caused by the separate independent sources acting along. Got it? Don't worry by seeing this statement. I will explain this theorem in a simple manner with examples. The response mentioned here may be a current or voltage. One more thing I would like to add. Superposition works for voltage and current, but not for power. As you know, power relations are not linear. Henceforth, we cannot use superposition theorem for power calculation. Alright? Now take a look at this example. Here we have two independent voltage sources V1 and V2 and a resistor R. I is marked as current through this part of network. Based on superposition theorem, we can say that this current I can be calculated by adding the current through this path caused by the independent source V1 acting alone and current through this path caused by independent source V2 acting alone. Let me ask you something. How we can calculate the current or voltage due to a particular independent source acting alone? Can you guess? For calculating current or voltage caused by an independent source acting alone, we have to replace all other independent voltage sources with short circuits and all other independent current sources with open circuits. Clear? This is an important point. I repeat, for calculating the current or voltage produced by an independent source acting alone, we have to replace all other independent voltage sources with short circuits and all other independent current sources with open circuits. Okay. So here let us first calculate the current caused by this independent source V1 acting alone. And for calculating that, we are supposed to replace this independent source V2 with a short circuit. After doing that, our circuit will be like this. I1 is marked as current produced by V1 acting alone. Here we have a voltage source V1 and resistor R. Correspondingly, this I1 can be easily calculated by using Ohm's law. Okay. Next, what we are going to do is we are going to calculate the current produced by V2 acting alone. And for calculating that, we are supposed to replace this V1 with a short circuit. After doing this, our circuit will be like this. I2 is marked as current due to V2 acting alone. Here also we have a resistor and a voltage source. So this I2 can be easily calculated by using Ohm's law. Finally, our desired current I can be written as I1 plus I2. Clear? Hope you got a more clear picture of superposition theorem. Let us understand this better with some problems. The first question I have for you is use superposition principle to find Ix in the circuit shown. First of all, take a look at this circuit. Here we are asked to find out the current Ix through this 9 ohm resistor. We have two independent sources here, a 3 volt voltage source and 2 ampere current source. Based on superposition theorem, this current Ix can be calculated by adding current to 9 ohm in downward direction caused by 3 volt voltage source acting alone and current through 9 ohm in downward direction caused by 2 ampere current source acting alone. Let us first find out the current caused by this 3 volt source, and for calculating that, 2 ampere current source is replaced with a open circuit. Okay. After doing that, our circuit will look like this. Here we have only a single loop and Ix1 is marked as current to 9 ohm in downward direction caused by 3 volt source acting alone. By analyzing this loop, it is clear that Ix1 is flowing through the surface of loop. Hence, Ix1 can be marked as this loop current. Okay. Next, the polarities of voltage drop across each resistors are marked according to the direction of Ix1. You know, a current always flows from higher potential to lower potential. So when we look at 6 ohm, the current flows from left to right. Correspondingly, the left point is marked as positive and the right as negative. Similarly, in 9 ohm, Ix1 is flowing from top to bottom. So the top, we mark positive at top and negative at bottom. Okay. Next, what we are going to write KVL equation for this loop. Starting at this point, first we observe this 3 volt voltage source with polarity marked order minus plus. Hence, we start our KVL equation with minus 3. Next, the voltage drop across 6 ohm, which is equal to Ix1 into 6 with the polarity marking the order plus minus. So we add a plus 6 Ix1 term to our KVL equation. Finally, the voltage drop across this 9 ohm, which is equal to 9 into Ix1 with the polarity marking the order plus minus. Correspondingly, we add a plus 9 Ix1 term to our KVL. Finally, we get our KVL equation as minus 3 plus 6 Ix1 plus 9 Ix1 is equal to 0 or 15 Ix1 is equal to 3. From this, Ix1 is obtained as 0.2 ampere. Clear? Okay. Next, we are going to find out the current through 9 ohm due to independent source 2 ampere acting alone. And for calculating this 3 volt independent voltage source is replaced with a short circuit. So our circuit will be like this. Here Ix2 is marked as current through 9 ohm in downward direction, okay, due to this 2 ampere current source. You can see this 2 ampere divides between these two resistors 6 ohm and 9 ohm at this point. Hence, by using current division rule, the current Ix2 through this 9 ohm can be written as Ix2 is equal to 2 into 6 by 6 plus 9. Hope you are already aware of current division rule. Correspondingly, Ix2 becomes 0.8 ampere. Thus, we calculated two currents Ix1 and Ix2. Based on superposition theorem, our desired quantity Ix can be written as Ix1 plus Ix2, that is equal to 0.8 plus 0.2, that is equal to 1 ampere. Got it? Clear? Okay, I have one more question for you. For the circuit of the following figure, use superposition principle to obtain Ix. Here Ix is marked as current through a 15 ohm resistor from left to right. Let us first analyze this circuit. Here we have three independent sources, a 2 ampere current source, a 3 volts voltage source and a 3.5 volt voltage source. So let us first find out the current due to independent source 2 ampere. For calculating that, the other voltage source is replaced with short circuit and the other current source is replaced with an open circuit. After doing, our circuit will be like this. Ix1 is marked as current through 15 ohm due to 2 ampere source acting alone. Here also you can see this 2 ampere current divides between these two resistors at this point. Correspondingly, we can write current Ix1 as 2 into 7 by 7 plus 15. This is by using current division rule, and that is equal to 0.636 amperes. Okay, clear? Next, we are going to calculate the current due to 3 volt sources acting alone, and for calculating that, the other voltage source is replaced with a short circuit and current source with a open circuit. After doing this modification, we get a network like this. Ix2 is marked as current through 15 ohm due to this 3 volt voltage source. Here you can see we have one loop and Ix2 is a current flowing through the surface of loop. Hence, this Ix2 can be considered as the loop current. Next, the voltage drop across the 7 ohm and 15 ohm are marked according to the direction of Ix2. You know, the current always flows from higher potential to lower potential. Here, Ix2 flows from bottom to top through 7 ohm. Hence, the positive is marked at bottom and negative at top. Similarly, Ix2 flows through 15 ohm from left to right. So, we mark positive at left and negative at right. So, now what we are going to do is we are going to write KVL equation for this loop. Starting at this point, first we observe 3 volt source with polarity mark in the order minus plus. So we start our KVL equation with the minus 3. Then the voltage drop across 7 ohm, which is equal to 7 into Ix2 with the polarity mark in the order plus minus. So we add a term 7 Ix2. Finally, the voltage drop across 15 ohm, which is equal to 15 into Ix2 with polarity mark plus minus. Correspondingly, we add a 15 Ix2 to our KVL equation. That is equal to 0. From this we get Ix2 as 0.136 ampere. Got it? Okay. So next we are going to calculate this current due to 3.5 volt sources acting alone. For calculating that, first we replace all other voltage sources with a short circuit and current sources with open circuit. After doing, our circuit will be like this. Here we have two loops and Ix3 is marked as current through 15 ohm due to 3.5 volt acting alone. You can see this Ix3 is the current flowing through the surface of this loop. Hence, Ix3 is marked as the loop current here. Then I1 as the loop current in next loop. First, we are going to apply KVL in this point, in this loop. Starting at this point, the first voltage drop we observe is that across 5 ohm, which is equal to 5 into I1 minus I3 I1 minus Ix3. Then voltage drop across this source, that is equal to 3.5 with the polarity mark in the order plus minus. Correspondingly, we get a KVL equation I1 minus Ix3 into 5 plus 3.5 is equal to 0, or 5I1 minus 5Ix3 is equal to minus 3.5. Okay, this is marked as equation number 1. Next, we write KVL equation for the second loop. Starting at this point, first we observe the voltage drop across 7 ohm, which is equal to 7 into Ix3 with the polarity mark plus minus. So we add a term 7Ix3 to our KVL equation. Next, the voltage drop across 15 ohm, which is equal to 15Ix3 with the polarity mark plus minus. Correspondingly, we add 15Ix3 to our KVL equation. Finally, the voltage drop 5 ohm, which is equal to 5 into Ix3 minus I1 with polarity mark plus minus. So we add a term 5 into Ix3 minus I1, that is equal to 0. Or we can write 27Ix3 minus 5I1 is equal to 0. Let it be equation number 2. By solving equation number 1 and 2, we get I1 as minus 0.859 ampere and Ix3 as minus 0.159 ampere. Okay. Finally, we can write our desired quantity Ix as Ix1 plus Ix2 plus Ix3, that is equal to 0.636 plus 0.136 plus 0.159, that is equal to 0.613 amperes. You all enjoyed this lesson. Thanks for watching. Thank you.